Hi Year 12. Some of you have asked about this question. Find the mass of one atom of fluorine in kilograms given the following data. Give your answer to the appropriate number of significant figures. And you're given the mass of the electron, the mass of the proton, and the mass of the neutron, all in kilograms, which is great because it's asking you for kilograms. So the first thing you've got to do is work out in this atom how many electrons, protons, and neutrons there are. So just like you used to do at GCSE, we've got fluorine, 19 and 9. If I just write underneath P and E, protons, neutrons, electrons. The bottom number is the atomic number. That means, which is the number of protons. So we've got 9 protons. In an atom, which is the question's about an atom, not an ion, the number of protons equals the number of electrons. So there's 9 of those as well. And then in this atom, the number of neutrons is 19 minus 9, so the mass number minus the atomic number, which is 10. Then we've got to use these numbers, these ones, to work out the total mass of that atom. So we literally take how many of these we've got and multiply it by this mass. So because I start with protons here, I'm going to start with the protons first. So we've got 9 protons that have a mass of 1.6726 times 10 to the minus 27. And we have 10 neutrons, so we've got 10 times 1.6749 times 10 to the minus 27, plus 9 electrons, done those ones, onto this one. 9 electrons, which have a mass of 9.1094 times 10 to the minus 31. So much smaller. So if we literally did that in our calculator and added all of that up, we would get the mass of the atom. Now I've made a rookie error and I have not brought a scientific calculator home with me. So I'm doing this on my computer. Here we go. And the answer that I've got is 3.1811 times 10 to the minus 26 kg. Now, the question asks you to put it to a suitable number of significant figures, appropriate number, I should say. Now, each of these numbers, they have been given to you to 5 significant figures. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, you can leave that to 5 significant figures because your smallest number here has also been put to 5 significant figures. So in terms of your accuracy in chemistry, I know it's different in maths, you can put it to 5 significant figures like I've done there. The second question, question B, find the mass of 1 mole of atoms in kilograms. Give your answer to the appropriate number of significant figures, and you've been given Avogadro's number, Avogadro's constant there, so there's a clue. So we know here the mass of 1 atom of fluorine in kilograms. All we've got to do for question B is take that 1 atom mass, which is tiny, and multiply it by Avogadro's number, which is 6.022 times 10 to the 23. Again, I'm going to my computer as my calculator here. And I am getting 0.01916 kg. Now, in terms of significant figures, this is to 5, but you're multiplying by a number that's to 4. 1, 2, 3, 4. So you can only be as accurate as your smallest number of significant figures. So that is why this needs putting just to 4.